Conformation isomerism. Before proceeding about conformation isomerism, we need to know some introductions about the conformation isomerism. Some important terms about the conformation isomerism which is required to know conformation isomerism. First of all, we will learn about the free rotation. What is free rotation? As this diagram, this is the similar diagram I have shown in to make you understand what is free rotation. Suppose these two carbon atoms in any compounds, if two carbon atoms is present which is joined by sigma bonds, it is not a pi bonds, triple bonds, not, it is not like this is a sigma bonds, means single bonds. If two carbon atoms are joined by a sigma bonds, maybe carbon, maybe nitrogen, maybe any other atoms is possible, but the bonds must be a sigma bonds. If any atoms is there, by replacing carbon, if any other atom will be there in place of carbon, that is okay, that is fine, but the bonds which is joining the two atoms must be a sigma bond, sigma single bonds. If any compounds two atoms having joined by a sigma bonds, then there is a possibility of free rotation about this bond. There is a possibility of rotation about these bonds. How they are rotated, I will show you here. In this way, there is a possibility of rotation about this sigma bonds. It is shown in the three dimensionals. Here black is we are learning organic chemistry, so we are taking the carbon atoms, but if you learn any organic, inorganic, any other things, we can take any other atoms. But here is a black is carbon. I have denoted this black is carbon. Here is this white is hydrogen. This carbon hydrogens, 3 bonds and one carbon bonds. So this carbon fulfilling this 4 valency of atoms, and this is carbon is tetravalent, so that is fulfilling the 4 valency by making 4 bonds. This is a 1 bonds, carbon bonds, this is a carbon hydrogens bond, carbon hydrogen bonds, and this carbon is also having carbon hydrogens. This is also red, having hydrogens. I have shown this is red because I want to show that there is a rotations. So this is rotated. Now previously they are in the this way, this hydrogens in upper side, here is also hydrogens upper side, but after the rotation this red gone some get some rotations, get some degree of departure from the original positions. So this is in the slightly in, under the page, slightly to away from us. Now this is how look like this is upper side. Similarly, previously this is in the upper side, this is in upper side, but now it is rotated and slightly shifted from its original positions. Now if the rotation is occur, again, then this hydrogen, red hydrogen, will go in downward direction. Now this will go in downward directions, and these two hydrogens will go in upper direction. This will move upper, and this red will go in downward. So there is a possibility of rotation. Actually, I want to make clear that if two atoms are joined by sigma bonds, then there is a possibility of rotation about these sigma bonds. So this rotations occur, and this type of conversions, this type of compounds we will get after the rotations. Now this here is also sigma bonds is shown. If this is rotated, then now this is in a bond order. In this sigma bonds, all bonds are shown in sigma bonds, only straight lines shown. But actually this sigma bonds is like a symmetrical bond. It will like a cylindrical bond. This is shown between these two carbon atoms. Sigma bond is there, but they are in the form of cylindrical. And there is a minimum repulsion between them. This is called the free rotations. We define the sigma bond joining the carbon atom is symmetrical and symmetrical about the joining the two carbon atoms. Here is a symmetrical. The line joining the two carbon atoms is symmetrical and cylindrical. Here shown two carbon atoms are cylindrical and symmetrical. How their rotations occur? This way their rotations occur. These hydrogens going in downward directions. Actually, in these structures, in this figure, I want to make clear that there is a rotations is possible in the sigma bond. How they are rotated? one keeping the, this is keeping the same positions, this can be rotated. Here I have shown by the rotation this hydrogen is going downward directions, now this is in the upper directions. In this way the rotations is possible in the sigma bond. The energy does not differ much in different arrangement. The molecule can rotate about this carbon-carbon sigma bond. If these two compounds here, if energy much not differ, means by the rotation these compounds changes to these compounds, then there must be a energy difference between these two compounds. If the energy difference is not much greater, then there is a possibility of conversion from one to another by the rotation about sigma bond. We describe this freedom of to change by saying that there is a free rotation about a carbon-carbon sigma bond. This is the changes from this rotation is occur about the sigma bond. This is called the free rotations. Free rotation about the sigma bond. This is a freedom of change from one structure to another structure by the rotation about the sigma bond is called the free rotations. Now I have made clear the free rotation. What is free rotation? Now we will learn about there is lots of things, but I am explaining little things in startings so that you can understand the whole the things. Now this is a compound. Carbon is backward side, one carbon is the front side. Two carbon are joined by a sigma bond. This is a sigma bond. Now this carbon hydrogen bond is in the straight upward side. This is in a straight upward side. This is in a backward side. This is in a front side. This is in a front side. And this hydrogen is in the backward side. This is in a backward side. All the are aligned 1 to 1. Means this is in upper side. Now this carbon is backward. Here I am showing that we can view that both are look like in the front, but actually this is in the back, this is in the front, and this is in upper side, and this carbon hydrogen is also in the upper side, just back of this front carbon hydrogen bond. This is a front carbon hydrogen bond, and this is a back carbon hydrogen bond, which is exactly back of this front, and this is a front, and exactly this is in the back of this carbon hydrogen bond is exactly in the back of this carbon hydrogen bonds. If you'll view from this side, from the front carbon, we cannot view this carbon. If you'll view from this front carbon hydrogen bond, this carbon hydrogen bonds, then we cannot view this carbon hydrogen bonds. Actually I have shown this in the slide view. Slide view means not from this front carbon side view, slightly in a right upward side view, so that you can understand that this carbon is in the back. But after the rotation, if suppose front carbon is rotated by keeping this back carbon, all the carbon hydrogen bond is fixed, and this front carbon hydrogen bonds are rotated about this sigma bonds. There is a free rotation is possible about the sigma bonds. If there is a rotation is occur about some 60 degree, if you rotate some 60 degree, then this carbon hydrogen bond in the upper side, now it will rotate slightly. Now after the rotation, they will bisect this carbon hydrogen bond. There is a 120 degree in the backward side. This is a 120 degree, but after the rotation of this, here previously this is a front, and after the rotation they become this position, 60 degree rotations. Now after 60 degree rotation, this come in this position. This will bisect. There is a 60 degree rotation, but backward side this hydrogen bond angle is 120 degree in the backward side carbon atoms. Now this front side carbon atoms, there is a 60 degree rotation, so that's why it will bisect the angle between this hydrogen. This will this will bisect the angle by 60 degree. After the rotation of 60 degree of front carbon hydrogen bond, it will bisect the backward carbon hydrogen bond by 60 degree. This is called the eclipse conformation. This is a eclipse format because there is a 0 degree of rotations when front side and backward side carbon will look similar. The arrangement looks similar. There is no any angle difference between this CH bonds and this HCH bond. There is no any angle difference. Here 60 degree bisecting angles. So in the eclipse, this is a eclipse conformation. Here eclipse conformation, the CH bonds on one carbon are directly aligned with the CH bond on the adjacent carbon. Here the CH bonds is directly aligned with this CH bonds. The backward carbon and front carbon CH bonds will align, 1 to 1 align. There is no any angle difference between front and back CH bonds. But after the 60 degree rotation, there is a difference in angle. Angle changes. The CH bonds on one carbon bisect the SCH bonds angle on the adjacent carbon atoms, and this is adjacent. This CH bonds on one carbon will bisect the HCH bonds angle on adjacent carbon. This is adjacent carbon, backward carbon, and front carbon. These two are adjacent carbon. This front carbon will bisect the adjacent carbon, backward carbon, hydrogen's bond by 60 degree. We can simply say they are bisecting. In this way, we can form two conformation. This is eclipse conformation. If there is 1-1-1 alignment, CH bond 1-1 alignment, upper side, there is a 1-1. One is front, one is back. If you will view from the front side, we cannot view the backward side carbon hydrogen's bond. Now here we can view that this is an upper side, this is in a this side, so we can view from the front side. If you view from this front side, then we can view that this is a in the upper side carbon hydrogens, and this is in a slightly rotated by 60 degree. This is a stage conformation. This is 60 degree rotations. After that, we will getting the stage conformation. Rotating the atoms one carbon by 60 degree convert an eclipse conformation into a stage conformation. Means after if you rotate the 60 degree eclipse conformation, we will get a staggered conformation. If you rotate a staggered conformation by 60 degree, then we will again get a eclipse conformation. This CH bond, if you rotate by 60 degree, then this will come in this position. This will align with this carbon hydrogen bond, backward carbon hydrogen bonds. This will align with this carbon hydrogen bonds. Means eclipse changes to a staggered by 60 degree rotation, and staggered also changes to eclipse by 60 degree rotation. Means 60 degree rotation, a staggered eclipse conformation we can get. The angle that separates the bond on one atoms from a bond on adjacent atom is called the dihedral angle. For ethane in the staggered conformation, the dihedral angle is for the CH bond is 60 degree. For eclipse ethane is 0 degree. Means here is the CH bond and CH bonds. In the both are aligning, there is a 0 degree in angle separations. But here 60 degree rotation, 60 degree rotation of front carbon. So there is a this is called 60 degree. The atom from one bond on adjacent atom is called dihedral angle. For ethane in staggered conformation, the dihedral angle for a CH bond is 60 degree. This is 60 degree. This is a dihedral angle. There are some angle apart. Means previously there is a 0 angle definition. Means front carbon, back carbon. This is a atoms. They are both are aligned in 1-1 in the back to back. So they are 0 degree angle definition. But after this rotation, and this carbon and this carbon, so if you come to this position, if you front carbon make bring these positions, and we can easily say there is a 60 degree angle definition. Now we have learned the eclipse and staggered conformation. We will learn again eclipse and staggered conformation, but here for the introduction purpose about the conformation isomerism, I am explaining this. So there is a angle 60 degree. This is called a dihedral angles. Looking directly down the CH bond, there is a 0 degree angle difference between front CH and CH bonds. Here is CH bonds front, and this is a back. If this is a front, this is in a back carbon atom CH bond, and this is a CH bond. How if you want to see the dihedral angle, how much the dihedral angle, then we have to bring this same positions. Now this is a back carbon atoms, now this is a front carbon atoms. Now both are in the 0 degree, but after the 60 degree rotations, they will look like this. If you bring this front into the back carbon atoms to see the dihedral angle, then there is a 60 degree dihedral angle. In this way I have explained what is dihedral angles. Now there is a special type of conformation used to represent the conformational isomerism. Generally, most of the times we use a special type of conformations. Most projections, a Newman projection is used Especially this Newman projections maximum types are used to represent the conformation isomerism. To different type of conformation isomerism, a special type of projection I use is called Newman projections. To in down representation for conformation and commonly using a convection called Newman projection. Means to represent the conformation isomerism 2, 3, 4, 5, 6 conformation we want to represent, then generally we use a Newman projection as a techniques, as a procedure, as a diagram to represent the conformation isomerism. So how to draw the from the end view? This is all the end view. This is a end on representation. This is a end on actually how the atoms are arranged. This is shown, but each time this is not possible to represent this carbon, this hydrogen in this way. So use a representation, a projections to represent a conformation isomerism that is called Newman projection. The how Newman projection will look like, the process I will tell you later. But this is the Newman projection. How the clearly are viewed. This is the front carbon atoms. Now and back is the our backward carbon atoms. Here in the back side, but it is not shown. Actually, in the back side there is a backward carbon atoms. This is a front carbon atoms. Carbon atoms, front carbon atoms is 3 bonds are joining, and backward carbon atoms also 3 bonds are joining. Actually, this is the front carbon atoms, and this is shown in the backward side. This is a backward carbon atoms. It is shown in a dot. This is shown in a circle. So this dot has a 4 hydrogens, and this backward also has a 4 hydrogens. They are actually showing, but not actually look like this. But we are representing the conformation isomerism. How the from end view, how the conformation isomerism change is showing by the Newman projections. How to this is a end to end view. This is a front. Now this is a back. This is a front carbon atoms by dot. A front carbon atoms is shown. A backward carbon atoms is shown like a circle. Now front carbon atoms also has a 3 bonds. Now this front carbon also has a 3 bonds. Now this is a front carbon atoms, and now this is a backward carbon atoms. Front carbon atoms has a 3 bonds. Here it is shown 3 bonds. Now 1, 2, 3. Now backward, this is a circle is a backward carbon atoms. Backward carbon atoms also has a 3 bonds. No, 3 bonds. In this way we can represent the in view in the Newman projections. The conformation isomerism can be shown. This is an staggered conformation. Now there is a 60-degree dihedral angle, means staggered conformation. If this will be like this, not like this, this will be the eclipse conformation. This is a staggered, this is a eclipse conformation. Now I will show you better way. 3 bonds, front carbon 3 atoms, 3 bonds. Now backward also has a 3 bonds, 1, 2, 3. Now there is a 0 degree. Actually I have shown this is in a slightly in the left, but actually this is in the back. This is a front, this is in the back. Exactly this is in the back to align this front carbon hydrogen bond. But I am showing in the papers to know that this is in the backward side. I have slightly draw in different positions to show that there is a 1 CH bonds, but actually this is in the back. We can also draw in this side, this side, this side, any side, but this is in a proper way. If this is in a right, this is in a right, this is in a right position of this front carbon hydrogen bond. This is in a eclipse formation because there is a 0 degree angle between CH front, CH back to back align, one to one align, but there is a 60 degree angle departure from the CH bond to this CH bonds and this CH bonds. There is 60 degree angle departure, but this is a dihedral angle. Now we will learn very much things. We need to learn. I will learn one by one each thing again. But for the introductions to know little bit about the conformation isomerism, I explain that much things. But I will again explain the staggered eclipse conformations. Now I have completed these things. The Newman projections. Now this is how the Newman projection are representing. I will explain one by one the conformation isomerism standard definition, all the things one by one I will explain.